Okay, the first three terms of a pattern are shown. Draw the next two terms in the pattern. So again, look at what's happening. You have 6 dots here, 3 down, 2 across. You now have 3 down, 3 across, 3 down, 4 across. So it would follow the same pattern. Okay, 3 down, 5 across, 3 down, 6 across. You can count the dots. So that's term 4 and that's term 5. Okay, count the number of dots in each of the first 5 terms and display your results in a table. So again, there's 6 dots here, there was 9 dots there, there's 12 dots here, there'd be 15 in term 4 and there's 18 in term 5. Okay, so there's my table. Describe the sequence of numbers generated by the pattern. Well, it's a linear sequence, otherwise known as an arithmetic sequence. Why? Because the first difference is constant. They're going up in 3s every time, so 3 more dots was added on each time. So it's a common difference of 3. How many dots are in the 9th term? So you could just continue it on. Like that was term 4, term 5, term 6, term 7, term 8, term 9. There are 30 dots in term 9. How many dots are in the nth term of the pattern? So that means find the T of n formula. So it's a linear sequence or an arithmetic sequence. So you can use the T of n formula from the log tables, page 22. Okay, A is the first term. The first term was 6 because there were 6 dots in term 1. The common difference was 3, so we sub in. Okay, they asked us to get, sorry, they didn't ask me to get term 8, so ignore that. It was a different question. They'd actually asked to get term 9, which we did, which was 30. But the T of n formula, it's going to be A, which is 6 plus n minus 1 times the common difference, which was 3. Multiply the 3 into the bracket. You'll get 3n minus 3 and then tidy it up. 6 minus 3 is 3. There's your T of n formula. Question 2. The first 3 terms of a pattern are given below. So term 1 has 4 dots in it. Term 2 has 7 and term 3 would have 10. Okay, draw the next 2 terms in the pattern. So it was 3 across, 2 up. Then it's 5 across, 3 up. So you can see if the one's going up, it's 2, then it's 3, then it was 4, which means the next pattern will have 5 going up. And there's an equal number of dots on either side of the middle dot. So there was 1 on either side of the middle dot there. There was 2 on either side of the middle dot there. There's 3 on either side, so there'll be 4 on either side of the middle dot in term 4. Okay, term 5. You can see there are 6 dots going up the middle, and then there are 5 dots on either side of the middle dot. So you can then count the dots. Part 2, count the number of dots in each of the first 5 terms and display your results in a table. Okay, there's your table. So 4, 7, 10, 13, 16. You'll notice they're jumping by 3 each time. That's what makes it a linear sequence or arithmetic sequence. Describe the sequence generated. It's arithmetic. Why? Because the common difference is 3. How many dots are in the 9th term? So we've already done it for the first 5 terms. So you could just keep adding on 3 to get the 9th term. And term 9 works out to be 28 dots. How many dots are in the nth term? So the T of n formula. So put down the T of n formula from your log tables, which is T of n equals A plus n minus 1 times D. Okay, your value for A is your first term, so A was 4. Common difference is 3 every time, so sub in 3 is D. Multiply 3 into the bracket, so you'll get 3n minus 3. And then group your like terms. 4 minus 3 is plus 1. So your T of n formula is 1 plus 3n. Question 4. Minus 11 minus 15 minus 19 is an arithmetic sequence. So they're already telling you it's linear. Find the nth term. That means find the T of n formula and hence, using what you just did, write down the 55th term. So I'll write down the T of n formula. A is the first term, so A is minus 11. And then to get your common difference, term 2, take away term 1. So that would be minus 15, take away a bracket minus 11, which would end up being minus 15 plus 11, which gives you back minus 4. So they are going down in 4s each time. Okay, to go from a minus 11 down to a minus 15, you've gone down 4 units. So common difference D is minus 4. Okay, so I've subbed into my T of n formula from the log tables. A was minus 11, D was minus 4. Multiply minus 4 into that bracket and you'll get minus 4n plus 4. Minus 11 plus 4 is minus 7. So my T of n formula now reads as minus 7 minus 4n. Hence, it said get the 55th term. So term 55, So now n is 55, sub it into what you had just done, and you get minus 227. Question 5. The following sequence is an arithmetic sequence. Find the nth term and then hence find the 85th term. So A is 0. Common difference each time, it's going up by 7. So D is 7. Okay, so subbing into my T of n formula, multiply 7 into the bracket and you'll get 7n minus 7. And obviously 0 doesn't affect it, so there's your T of n formula. Hence, get the 85th term in the sequence, so term 85. Replace n with 85, sub it in using brackets, and you get 588. Question 8. 116 is a term in an arithmetic sequence. 14, 17, 20, so they're going up by 3s every time. Okay, 116 will eventually be, off down here somewhere. Which term is 116? So that means find n. N represents the term number. So like 116 might have been the 17th term. It could be the 12th term. We don't know. So the first thing you need to do is come up with your T of n formula for that sequence. So A is 14 and the common difference D is 3. Once I have my T of n formula, I can let the T of n formula equal 116 and figure out what n is. So figure out which term 116 was. Okay, so subbing into my T of n formula, A was 14, D was 3. Multiply 3 into the bracket and you'll get out 3n minus 3. 14 take 3 is 11. So that's your T of n formula. So now that I know what the nth term is, they told me one of the terms is 116. Let your nth term equal 116 and solve for n. So remember, you're not being asked to go and get the 116th term. That is not what they said. They said one of your terms is 116. So let your T of n formula equal 116 and solve for n. And you will eventually get out that n is equal to 35. Therefore, the 35th term in that sequence is 116. You can check if that's correct. If you now sub 35 into your T of n formula here, so to be 11 plus 3 times 35, you will get back 116. So you'll know that your value for n is correct. So the 35th term is 116. Question 9. The 51st term of an arithmetic sequence is 248. So term 51 equals 248. If D, the common difference, is 15, then find A. Okay, well, we're going to come up with our T of n formula. We know what D is, we just don't know what A is. But the 51st term should equal 248. Okay, so T of n is A plus n minus 1 times D. A we do not know, leave it as A. D, the common difference was 15, so I can sub in 15 next. They also told me that term 51 should equal 248. So if I sub in everything I have, right, n is going to be 51. So it's going to be A plus n, which is 51, minus 1 times D. D was 15. 51 take away 1 is 50. 50 multiplied by 15 is 750. So term 51 equals A plus 750. But they already told me that term 51 is 248. Well, therefore, the expression for term 51 should equal the value of term 51 and solve for A. Bring the 750 over and subtract it, and you'll get your value for A as minus 502. So the first term in that sequence was minus 502.